Hello, and thank you for standing by, and welcome to the 6th episode of the World Series on Data Virtualization. Today's topic is on value-added customer technical services, practical challenges overcome with data virtualization, which will be presented by Vikram Kalyanaraman, Manager of Smart Analytics at Cisco Systems. My name is Kim Lukens, and I am the moderator for the World Series on Data Virtualization. Please note that the webinar is being recorded and will be made available for on-demand viewing following the event. Denodo Technologies is sponsoring this series of expert talks on data virtualization throughout the rest of 2011. For today's presentation, I'd like to invite Angel Vina, CEO and founder of Denodo Technologies, to share with you some key points to kick off the episode of the World Series on data virtualization. Angel?
Many thanks for attending this webinar. My name is Angel Vina, Chief Executive Officer at Denodo Technologies. On October 28th, the St. Louis Cardinals raised the Commissioner's Trophy at the 2011 Major League Baseball Championship, the World Series. To receive that honor, the Cardinals strove for excellence. Our World Series on data virtualization is likewise about building champions. Data virtualization champions that can contribute with excellence to data management innovative architectures and solutions. This is our goal and our hope with a special program of 13 different webinars this fall. We are now in webinar number 6, and for today's session, a data virtualization user will share a big story with the audience. I want to emphasize here the word big in 4 different ways. It is a story of a big company, a global leader, always at the cutting edge of innovation, very savvy on IT technology. A story of big data, involving huge data volumes distributed in many file systems, databases, and data warehouses. It is also a good story on how to solve a big problem. A service provider trying to deliver a new generation of high-value data services to very demanding corporate customers. And definitely, a story also big for the size and global scope of the deployment. Additionally, the experience of this company using data virtualization highlights the company's evolution from an initial limited project where data virtualization was a small architectural component to a wider and richer vision where data virtualization is now the core solution for data access, data integration, and data provisioning. This silent progression in architectural relevance that grew parallel to the team's own growth in knowledge and experience on data virtualization shows the extraordinary potential of this technology to solve important data management problems. The company is Cisco Systems. Our guest speaker, Vikram Kalyanaraman. He's a leading manager of Smart Analytics within Cisco Customer Services Business Unit, responsible for the successful implementation of several initiatives under this umbrella. He has served in other technical and business roles at Cisco and at Infosys Technologies prior to that. Vikram is an enthusiastic technologist, a pragmatic professional, and a great speaker. Without further ado, join me in welcoming our guest today, Vikram Kalyanaraman.
Thank you, Angel, for that introduction, and thank you all for joining this session. I'm Vikram Kalyanaraman, and I run an engineering team for the Smart Analytics group within Cisco Services. I am responsible for analytic exploration and incubation, as well as for the implementation of analytics-based software applications within our Smart Services portfolio. I have over 12 years of experience in the industry and have worn many hats through the years, including things like program management, product serviceability, and software engineering. For me, the common theme across all these roles has been data. That's over 30,000 hours of working with data. Now, here's my email ID in case you'd like to get in touch with me. So today, I'm going to talk about some of the practical challenges that can be overcome with data virtualization. To start with, let's set some context around my current area of work. About 6 years ago, Harvard Business Review defined smart services as those that use automated and technology-enabled connectivity and intelligence to more effectively deliver higher value. Now, Cisco Smart Services starts with the HBR definition and adds even more value by leveraging intellectual capital, incorporating real-time data analytics, and integrating partner expertise. Now, my group is responsible for smart analytics, which in turn delivers real-time data analytics capabilities to smart services. So today I will share some of the challenges that I have experienced dealing with data over the years and talk about how data virtualization as a technology can help address these challenges. So more specifically, I will talk about these challenges in the context of analytic exploration and incubation, as well as the development of web applications that serve data and information. So let's start with analytic exploration and incubation. Now, if you search the web today, you will find many definitions of analytics, many that are mind-boggling in their use of technical terms. But I like this simple and practical definition. Analytics is the process of obtaining an optimal or realistic decision based on existing data. Now, analytic exploration and incubation involves acquiring data, applying various statistical techniques and intellectual capital to that data, and then creating analytic models using that data. These models will ultimately help in making business decisions. Now, of course, there is a lot that goes on behind the scenes, but the key theme is that data is critical to analytics. So let's move on to some challenges then. There are 3 key challenges that I have experienced when it comes to data exploration. First, data acquisition. Data sources are widespread, both in terms of where they are located, as well as the type of data sources that you encounter. Now, Cisco, like just about any company of its size, has a centralized enterprise data warehouse. We also have other decentralized warehouses and data marts. We have lots of spreadsheets floating around. Many of these are created either manually or through reporting tools. Then we have PDFs, blogs, discussion forums, and social media. Now, in some cases, users have access to data via web apps, but not necessarily the underlying data stores. Now, this could be through APIs or just by interacting with the app itself. For example, you could run a search or generate a report from a web app. And then now we're really starting to see an explosion in the number of smart devices that have the intelligence to collect lots of data, including health and diagnostic information, that can then be sent back to the mothership. So that's a lot of data that we could potentially have access to. So now let's stop here and look at this. The first thing that you notice, obviously, is that the data may not be physically or logically located in one place. Secondly, all the data may not even be owned by your enterprise. For example, it could be a cloud-based social media service. And thirdly, the data kinds are not the same. For example, you have structured data, like relational databases that have an advertised schema. And then you have semi-structured sources like XML and HTML documents. And lastly, but not least, you have unstructured sources like PDF files and blogs. There's going to be a lot more, things like audio files and video files as well. Now, before we discovered data virtualization, our typical solution would have been to bring all this data together into a single relational database that could then be used for analytic exploration. To do this, we would have built components that read data from these sources. Then we would have built another set of components that handle semi-structured and unstructured data and prepare them for relational storage. Finally, like Cisco, if you use a tool set such as SAS for modeling, then you're most likely going to import data from that single database into SAS data sets. Once you're done with all of this, you can now proceed with your first iteration of modeling work. Now, as you can see, we've spent a lot of time architecting and building the entire workflow, and we've probably created multiple copies of data in the process. It is very likely that we haven't been able to get all the data that we wanted in the first place, especially data from, say, web applications that only provide results on screen. All this could get quite messy, and the odds of getting it right the first time are pretty low. Now, given the iterative nature of analytic modeling and exploration, this process will have to be repeated over and over. But thanks to data virtualization, a lot of the work that we did above can be greatly simplified. To start with, a good data virtualization platform comes pre-packaged with connectors to all popular data warehousing technology solutions. The data virtualization software also includes the ability to read data from structured, semi-structured, and unstructured sources, and it presents the data as views on which you can execute queries and searches. And of course, as the name suggests, you're truly creating a virtualized store and not another copy of the data, though the data virtualization platform will likely allow you to cache data for performance needs. A full-featured data virtualization platform also enables extraction of data from web pages. Now, this would include data that is either visible to or hidden from end users. It certainly enables extracting useful data from web apps that you could otherwise only interact with on screen. And finally, the analytic modeling tool can certainly import data through the data virtualization platform in order to enable data exploration and modeling. Let me illustrate data extraction with a real-life example. This is Cisco's support community website, on which you can find a list of support topics. Clicking on a topic displays a list of available discussions. Now, you can also see a list of popular tags in the form of a tag cloud. Now, the data virtualization platform that we use enabled us to quickly and visually configure a wrapper that navigated this website and extracted useful data. In this case, right from the tag cloud, with fields like the topic, the tag, and the number of times that the tag was used. Again, this includes data that is either visible to or hidden from the user. This data is then presented as a table. Now, here's the fun part. It took hours and not days or weeks to build the flow. And it took just seconds to actually execute. Now, clearly, with this technology, our focus can indeed be on exploring the data and conducting analytic modeling exercises, as opposed to spending most of your time and effort on just acquiring the data. And due to the ease with which you can acquire more data, the data virtualization platform makes quick loop iterations a reality. Now, that's extremely powerful, and that's how data virtualization can help in the acquisition of data for analytic exploration and incubation. So let's move on to the second major challenge. And that's about getting access to the data that you want to explore. I think it will be a lot easier to explain this with the help of an example. So here goes. One of the statisticians that I work with was exploring data within our trouble ticketing system. His intent was to study the structured data that we already have access to via daily import, in conjunction with the text notes contained within these trouble tickets. Now, the problem was that we did not have database access to these notes. In order to obtain such access, we would have had to engage with the business owner for the trouble ticketing system to run a concept by them, followed by a formal IT engagement to gain access if approved. So an engagement of this nature would typically involve planning well ahead, sometimes even 6 to 9 months ahead, in order to secure the resources, the funding, and the commitment for a release that would give us this requested access. Now, with such lead times, you would certainly want to get as much data as you can so that you have enough to work with for the next 6 to 9 months. And typically, you would get back to the drawing board and do as much as you can to uncover additional data that might be of interest. In other words, you are spending a lot of time and money on obtaining access to data that you don't yet know at this stage will give you what you're looking for. After all, you're still exploring the data, aren't you? So, data exploration is an iterative process. As you explore and as you learn, you're probably going to discover more and more sources of data that are of interest to you. Therefore, you need agility when it comes to exploring data for the purpose of analytic incubation. And the way I see it, you should be able to do most of your exploration without such formal engagements and huge lead times in order to be agile. So data virtualization as a technology can provide that agility, and that's where it comes to the rescue. So as I mentioned earlier, your internal systems may consist of web applications that allow you to search for and view data of various kinds. Now, in our case, we have an internal-facing web tool that allows you to submit a trouble ticket number and retrieve certain metadata as well as the entire history of notes for that ticket. So what we did was to use data virtualization features that would essentially pick each ticket number from a list of tickets, invoke the web tool and submit a request with that ticket number, and then retrieve the results of that query, specifically the notes, and then index them in order to be able to run text searches. Next, we built a view that combined the structured ticket data that we already had access to with index notes, etc., retrieved from this automated data extraction, all within our data virtualization instance. And finally, we connected our modeling tool to the virtual layer to continue our exploration. And how long did that take? Days, not months. So this solution more than meets the needs of analytic exploration at a very low cost and in an acceptable time frame. It also supports that iterative nature of data exploration. The best part is that you can explore and learn what data works best for you before you build a more formal solution using standard engagement processes. Again, very powerful. And that's one really cool way of using data virtualization for accessing data. Let's move on to challenge number 3. So this has to do with the increasing number of technologies that are available to support the growing world of analytics, especially with the phenomenal growth that we are experiencing in the amount of data being generated and stored. First, you have analytic toolsets like SAS and R that are used for data profiling and modeling. Then you have data quality and cleansing tools like Dataflux that can be used to improve the quality of data prior to modeling and to step up the quality of data profiling itself. Next, you have analytic database technologies like EMC Greenplum and ParExcel that can be used not only to augment the exploration and modeling of data, but also to persist results. And of course, you have data virtualization technologies like Denodo that can support the exploration of data. So as I mulled over these technologies and what they mean for analytics over a year ago, one thing became clear. There were going to be many ways in which we could connect these technologies together and likewise many ways in which one might want to sequence the flow of data through these components to meet different needs. Let's call these combinations design patterns. For example, we have a design pattern where we bring in data from many different sources: structured, semi-structured, unstructured. Then we run that data through a data cleansing tool and persist the results within analytic storage. We then import that data into our analytic modeling tool to run a predictive model. Finally, we combine the results of that predictive model with the data within our analytic storage to feed a web app that our users could access. Now, of course, we could do this with a lot of custom development, like I talked about in our challenge around data acquisition. Or you could use data virtualization as the glue to put it all together like this. My team recently tested 6 design patterns as a proof of concept, and in all cases, the data virtualization technology was the glue that held it all together, and in the process it eased development time and effort immensely. So that's challenge number 3, and a really nice way of using data virtualization to integrate various technologies across many design patterns. Let's move on to the second major challenge area, which is the development of web applications. Now, some of the challenges here include the fact that data sources can be moved, access credentials to that data can change, schemas and data models can change, old sources of data are retired, and new ones are added. Now, most such changes are accompanied by large development efforts involving many cross-functional teams and months of hard work. For example, let's visit the internal web app that is used to search for and review trouble ticket information. This app connects to a customer database, the trouble ticket database, and a file storage system that stores files that have been uploaded and attached to the trouble tickets. The app works well and has been optimized to perform well across these distributed data sources. Now, over the last few years, our IT has introduced some evolutionary changes. First, the customer database was migrated to a new data warehouse technology. Inherent in the migration were some schema and data model changes. Now, the developers not only had to modify the data access code to work with the new technology, but they also had to rework their code to cater to schema changes. This transformation was successful. It was performed, it took a significant amount of time to complete. And by the way, this change affected other applications too. So we're talking about other large similar efforts across the company. But that's not all. So just as we wrapped up that change, the next major one came along. The file system was being migrated to a cloud-based system with web services to enable file access and download. And of course, this resulted in another large effort to migrate existing apps to the new platform. But what if we had a layer between the web apps and the underlying data sources that could protect the web apps from such changes? Now that's where data virtualization comes to the rescue. By building a virtualized data layer that combines data from various sources, you can limit the changes that need to be made to just within that virtualized layer while retaining the web apps as they are. For example, if a data source is moved or credentials changed, you can change the location details or credentials within the virtual layer, and the web app will continue to work seamlessly. If the data source technology is changed, you can make appropriate changes within the virtual data layer, and again, the web app will continue to work seamlessly. If a schema is changed, the virtual data layer can include the appropriate mappings that would allow your web app and others to continue working. That's such an elegant solution and a perfect use of data virtualization technology to protect web apps from underlying changes. Now, what's exciting about data virtualization at Cisco is that it is becoming a key component of data and application architectures, which brings me to a good review point. I think this would be a great time to review some of the data virtualization capabilities that help overcome the challenges we've talked about today. I'd also like to bring up maybe a few other capabilities of interest that could ease the overall development process. So first, the ability to access data from various sources. This includes structured, semi-structured, and unstructured data. It also includes the capability that enables extraction of data from web apps that do not provide APIs. Next, the concept of abstraction or protection. That is, creating a virtual layer that protects applications from changes to the underlying data sources. Third, the analytic agility that is enabled by its support for data exploration and rapid prototyping, like in the example of the exploration of structured ticket data with ticket notes. Fourth, the support of service-oriented architectures by enabling data access via web services. The really cool thing is that this is even possible for data sources that have not been modernized or retooled yet for service-oriented architectures. For example, mainframes and flat files. Fifth, it's about the support for various design patterns as it pertains to integrating various analytic technologies and sequencing data flows. Sixth, data virtualization stacking. By this, I mean that one virtual layer can consume data or services from another virtual layer while offering data or services to a third. Now, this becomes extremely useful when organizations at different levels implement data virtualization. This certainly enables reuse and sharing. So, for example, the Smart Analytics platform consumes data from a higher level centralized data service layer through its instance of the data virtualization platform, right? Similarly, output from Smart Analytics can then be consumed by higher level data services through our instance of the data virtualization platform. So over the last 25 minutes or so, we have looked at some of the practical challenges that I have experienced in dealing with data, especially in the areas of analytic exploration and incubation, and then in the area of web applications that consume and serve data. And I've shown you how we at Cisco are using data virtualization to overcome some of these challenges. I do hope that this session was useful to you, and I wish you all the best in your plans and efforts to implement a data virtualization solution. Thank you, and over to you, Kim.
Thank you, Vikram. We've had some great questions come in. Thanks to those of you who have submitted questions so far. We welcome your questions and encourage you to send any additional questions after the webinar to dvworldseries@denodo.com. We will be reviewing all questions coming in and ensure they are personally responded to following the event. We encourage you to attend the entire World Series on Data Virtualization. If you have just joined the series, or if you've missed any of the earlier episodes in the series, please note that we have the recordings of the first 5 episodes available on demand. To view them, visit our website and navigate from the homepage banner to the page on the series where you will find the schedule with links to all the recordings. And mark your calendars for the rest of the World Series as we have some exciting episodes coming ahead. Our next episode will be on November 16th, titled Data Virtualization for Unified Data Services, which will be presented by Randy Hefner, VP and Principal Analyst with Forrester Research. This will be followed by a webinar on November 22nd titled Automating Trace Process for Positive ROI, a financial service case study that will be presented by Steve Cohn from Direct Legal and Collections. This webinar will also include a Denodo Advanced Technology session on advanced web automation, harnessing the web for virtual data services. Well, we have reached the end of the webinar for today. I'd like to thank our speakers, and I'd like to thank all of you for your participation. Signing off until next week, this is your host, Kim Lukens.
The World Series on Data Virtualization is brought to you by Denodo Technologies, the leader in data virtualization, delivering unmatched flexibility, performance, and ROI.